Hello everyone. So today we are going to discuss, how we can improve the performance of LLM when we are, working with the LLM interactions, right? So generally, what happens is like how we make a naive LLM application is something like this. So what will happen is user will come, user will send a query, the query will go to the LLM, LLM will generate a response and it will return it back to the user, right? But this kind of application works very well in your local, but the moment you actually move out from your local and deploy it to a production, and when millions and millions of users start using your application, one thing that you will observe is in most of the application there are around 80% of the queries which are repeated, right? And if you're building a system like this, what will happen is on those repeated queries also, you will be hitting the LLM every time, right? Now, how will it affect? Let us understand that if I'm hitting the LLM every time, so what, right? So let me tell you what happens in that case and how we can optimize it, right? So assume that there is some query saying what is the future of AI, right? Very simple query. Now, assume that you are hitting the LLM every time, every user who is asking what is the future of AI, what is the future of AI, you are every time going to the LLM and it is generating a response and giving it back to you, right? So what will happen is these LLMs are probabilistic models, right? Now, probabilistic models are somewhat like, even if you give it the same query, there is no guarantee that it will give you the same response, right? And why I'm saying this is because generally when we create an application with LLM interactions, which we wanted to sound a bit more humanized also, we generally keep a temperature of around 0.7 in that case, right? Now that is an ideal temperature for a chat application. And what happens in that is, even if I give the same query, just like humans, right? If you ask me the same question, there is no guarantee that I will every time give you the exact same answer unless and until I have memorized that answer, right? So that is what will happen, right? In the case of LLM as well, when the user will give the exact same query, it might give you somewhat different answer, maybe similar context, similar meaning, but word to word it will not match, right? But when we make a system in production, sometimes we want to know that what kind of answer it will be. Sometimes we want to take the answers also along with maintaining the humanized version of that, right? So the humanized version is generating the answer, right? Now if a user sitting in India and if a user sitting in US asking the same query, they do not know each other. If I am giving them the same answer also, it will not be like this LLM always gives me the similar kind of answer. And even if it is like that it is giving me the similar kind of answer, that is a good thing from a product's point of view, because you can guarantee on that hey, this is what it will return if this thing will come to it, right? That is number one. Number two, LLM, the currency in LLM is tokens, right? So for the same query also, if you are hitting it every time, what you are doing is you are wasting your tokens. And LLMs are generally charged on tokens, like you will be having the cost and per million token usage. Now think 80% of your users are hitting the same query, but instead of giving them the response, which could be generated once and given to everyone, you are generating it every time, so you are burning your tokens every time, right? Number three is LLM, since they are probabilistic model, they have thinking, they have reasonings and all. When you send a query, they take time to response, right? So there is a latency also involved. So what we have discussed, we are just going to see those things only. So what will happen is the token exchange on each interaction, input token, output token, process token. These are the tokens that we are going to consume for same query. Let's suppose 100 query comes, 80% of that is kind of on the similar line. Maybe about the war between US and Iran. Then what will happen is it will try and generate it every time, right? There will be high latency because LLM is every time generating it, right? And same question may have different answers, semantically similar but not exactly same. They are not word to word matching, right? So what should we do in such scenario? Let us understand that. So for this we will be using a system like this, okay? So in this, what will happen is when the user will make a query, like let's suppose first time the user is coming to a system, they will make a query, it will first check in the key value cache. If it is present, now it is a first time query, so definitely it is not present, right? So it will go next, it will vectorize the query for you, it will check in the semantic cache. Is it present? Not present, right? It will go to the LLM, it will generate the response for you, and then it will store the response in key value cache and the semantic cache, right? So the response is now let's suppose again exact same query came to you, right? So in that case what will happen, it will this time come over here and the key value cache will say, hey, this is a KV hit, and it will return it to the user. Okay, assume that it is a similar query, not exact word to word match, there is something different in the query, right? So in that case what will happen is the key value won't be able to answer in that case, but it will go to the semantic check, and semantic was having the answer from the previous LLM response. So this time it will check if the similarity score of that particular query is matching 85% to one of the candidates which is already stored in your semantic store, vector DBs basically, right? So what will happen is it will return it to the user. We are doing one more thing. If the score is more than 90% match, so in that case what we will do is we will store it in the KV also, right? So next time when that similar query will also come, so now your KV is capable of answering that similar query as well, that your semantic DB has actually seen, the vector DB has actually seen, right? So this is how we are going to build this system, and let us see that how it is going to benefit us. So key value will check for exact match, it has the least turnaround time. So when I will show you when I will show you the product, you will see that the turnaround time for a key value cache is the least, right? Semantic is the second in the race. So whenever there is a semantic, so because there is a like query embedding, and then it goes for a similarity check to the retriever, right? And then it returns you. So that is why it is slightly higher than key value, but it is much lower than your LLM. Okay, and your LLM has the highest response, plus it has the highest cost as well. Okay, so now let's come here and let me just come over here and let's do one thing. So here this is the interface right now. It does not have we have not asked any query till now. So let me ask some query over here. So who is better, Claude or OpenAI? So let me ask this query to this, right? And let's see what it says. Both Claude and OpenAI are AI models. Claude is known for its conversational tone, while OpenAI excels in generating human-like text, right? It depends on the task. If you need a chat-like experience, Claude might be better. For creative writing or in-depth information, OpenAI could be more suitable. Okay, so this is the Llama model, right, which has a knowledge cutoff and all. In today's term, if you see, Claude is definitely winning the race, right? Okay, but let me do one thing. Let me ask this same question again, and let's see. Okay, so both Claude and OpenAI are, but they serve different purpose. Claude is a conversational AI, while it is a general purpose, blah blah. So if you see, it is saying on the same kind of thing, but the response in both the cases are different, right? So because it is but I've given this exact same query, still the response, if you see the word to word match, it is very different. Okay, now let me do one thing. What I'm going to do is I'm going to enable the key value cache. Till now it was not storing it in the key value, but this time when I will ask the same query, what it will do is it will also store that response in the key value. Okay, let us ask. Okay, so you can see till now the source is always LLM. Both Claude and OpenAI are AI models with unique strength, blah blah blah. It is taking around 500 milliseconds. Now let me ask the same query again and let us see what difference will it bring. Oh, did you see? 500 milliseconds to this. So you can see that how fast first of all the response came. Second, since it was the exact same query, I know that what the response will be. There is no LLM involved, so no cost is there. The response was already generated, so I know that for the same query I will be getting this response only for every time. And third, the turnaround time is super less, right? Okay, so let us do now something more. I'll enable the semantic caching now, and I will ask who is better, Claude, OpenAI or Gemini, right? So let me ask about these three now, and let us see what it will say. Now, since I have not asked this query before, so definitely first time when I'm going to ask, it will go to the LLM, right? So it was doing some thinking, and you can see that this time it took around 1 second to respond, right? Cloud, OpenAI. So more the complex the query is, more time it will take, right? So you can see I have increased the complexity by including one more candidate here, right? Gemini are all model, OpenAI is popular choice, Gemini is from Google, Claude is the new model. Each has strength, but OpenAI is. And again, as I said, that since we are using the Llama model, which has a cutoff date, so that is why it is not up to date. If there is an up-to-date model, means if I'll switch from, let's suppose, Llama to Gemini, which is a cloud model which has the web search and everything enabled, right? So in that case, what you will see is, you will see the response will be a bit different from here, right? It will give you a much correct and much latest response, and that is why there are tools and all that we put to the LLM, so that they can do a good web research and then bring the response. Now, since this was a very simple example, I did not want to bring that kind of complexity. Okay, now let me do one thing. Let me ask the exact same query, and if you see our thing, if it is the exact same thing, it will go to KV and then it will return from there, right? So that is what should happen now, and that is exactly what happened. It went to the KV and it returned the response, right? Now let me tweak the query a little. So what I am doing is, instead of asking like that, I am asking like this, right? And this time what you notice is it went to the semantic store, right? Because it was not exact match, although I am asking the same question, but what I did is I have changed the language over here, but my vector DB was able to understand that it is the same question that came, right? And it actually, if you see, it is a word-to-word match to the previous response that LLM has generated, right? Now let me ask the same question again, and let us see what will happen, because we also have one more condition, that if it is a 90%, means more than 90% match, 90% or more matching, then I am also going to store it in the KV, right? So this time what we see is, it is for the semantic, earlier the response that came was more than 85% match, but not exact 90% match, so it did not go to the KV in that case, right? And that's why the semantic is actually returning it from there, right? But whenever the semantic DB will feel like this is kind of a 90% or more match, so what it will do is, it will also store it in the KV, is how we have coded, and in that case it will start returning that answer from the KV itself. Okay, so this is the example, and yeah, so this is how it has worked. You have seen all this. These are the what we say, the flags that we are sending. Let us also see the API before we jump into code. So this is the chat API that we are using. It intakes user query and boolean values for KV enabled and semantic enabled or not. Okay, so now let us jump into the code and see the code once. Okay, I'll come to the LLM model, and if you see this, it's a big project, right? I made it like a complete project, which has a front end, it has a back end, and it also has agents in it, right? And there is a Docker Compose, which actually, where I'm bringing my Redis image, bringing my Qdrant image, and then setting up my backend and my front end to run it. Okay, and let us come to the front end. The front end is a Streamlit application that I have made, and this front end is actually communicating with the backend. So you can see the backend URL over here, and what it will be doing is, it will be hitting the backend URL on the button click. So see, whenever there is a chat message, it will hitting the backend URL, and then it will be sending the prompt and the values of the KVs. It will get the response, and then it will pass the response and show it to you, right? So now let's come to the backend ones. Backend is a very simple backend we have made with FastAPI. There is one API that we have exposed. This API takes a request body, right? The request body, if you see over here, has message, KV enabled and semantic enabled. Same thing what we have seen over there. And then this calls the LLM that we are just discussing, right? So I made two implementation, one with Gemini, the other with Grok. Okay. So here is the Grok implementation. It's very simple. What we are doing is we are creating a Grok client, and we are calling this user message, right? We are checking. First we are pre-processing the message. Very simple things like making it complete lowercase, removing any extra spaces from front and back. Okay, and then we are calling. We are creating our message with a system instruction, which is like, you are a helpful assistant, answer the user message, take time and think before and all, and your response should be within 100 words. So that's why you see there are small responses, right? Because the smaller the response, faster it will be. And for this training I did not want to build a model which will give you a response in 5-10 seconds and all, right, just to prove my point. But when it is a production system, it generally takes that much of time, right? Okay, so now here what we are doing is we have if KB enabled, and here will be like, okay, result search key. So it will go to the KV cache, it will search for it, exact match. If it is getting it, it will return from there. If not, it will check for the semantic if that flag is enabled. If it is able to find a match, what it will do is it will also check if the score is more than 90%. In that case, it will add it to the key value also, as I have told you, and otherwise it will return, right? And we will see the 85% similarity matching thing in the semantic implementation. Okay, and then if both are false, in that case what will happen is it will come to the LLM. Means if you are not able to find the matches in both, in that case also it will come to the LLM, it will generate a response, then it will check if the flags were true, it will store it in them, right? So this is exactly how it was working. Let's come to the caching layer. We'll see the KV cache first. It's a Redis implementation, add key and search, just to very simple things over here. Message, we will be putting it in the Redis. Second vector DB is the Qdrant one that we are using, right? So first we are creating the Qdrant client. The client is created, we are creating a Qdrant collection, okay, and we are saying that we want it to be spaced with cosine, and we are going to use the mini LM LSV2, which is around 384 dimensions of encoding that we are going to use. We are using it from the Hugging Face itself, using the sentence transformer. Okay, now here is the add query, which is like the new query. If semantic DB is enabled, in that case any new message from user will come over here, will convert to vector DB. In the payload we will add the user query and the model response, and then we will upsert it. Okay, in case of search, it will again first it will convert it to vector embedding, and then it will check in the vector DB. If it is able to find it, it will check the candidate only which are matching more than 85%, right? So if you find a more than 85% match, then it will return it back, right? So this is the simple implementation that we just discussed. If you want this complete code, what you just need to do is you need to subscribe to the channel and comment GitHub link, and what I will do is I will share the GitHub link to your email ID, right? Along with the GitHub link, you just have to also mention your email ID, and I will share it with you. Okay, cool. So just keep learning. Let me know if you want tutorial on Qdrant also. I will be sharing that. The next tutorial that I'm planning right now is on the evaluations, the LLM evaluation, how to work on those. So yeah, stay tuned, we'll be uploading it very soon. Thank you.